students. Today in this video I have picked up two questions based on the topic we have discussed in the previous video. That is these are the previous year's JEE questions, and here this was asked in JEE to 2024. So if you look at this question, when Xi and Xi are two wave functions of atomic orbitals, then sigma star is represented by. So here while discussing the postulates of MOT, one of the sixth postulate, I think here it is, each atomic, what is the molecular orbital theory? Just let me revise one thing. Atomic orbitals combine to form molecular orbitals. Okay, so here how these atomic orbitals are combined, that was explained by taking LCAO approach. Linear. If you didn't watch that video, I'll provide the link in the description box, so you can go through that video. So you will get the answer for this question. So here linear combination, how these atomic orbitals are combined to form the molecular orbitals. To explain that, the process adopted was LCAO approach, linear combination of atomic orbitals. So here according to wave mechanics, each atomic orbital is represented like a wave function psi. So for example, you take an atom A. So here the two wave functions, when they combined, here will get when these two are in constructive interference, we'll get one atomic orbital with lower energy than these atomic orbitals A and B. Okay, when these are added up, constructive interference added up, we get a bonding molecular orbital Xi1 plus Xi2. When they are bonding molecular orbital, it is represented as sigma. So when they are in destructive interference, means when they are subtracted, there is a decrease in the amplitude also. So here when they are subtracted, we'll get another orbital with higher energy, that we call as antibonding orbital. Here antibonding orbitals are represented with a star. So here the new antibonding orbital, which is having higher energy than these atomic orbitals, which is formed by the destructive interference, means here when the two wave function are subtracted, we get an antibonding orbital. So now the question is, when Xi and Xi are the two wave functions of atomic orbitals, then sigma star is represented by, here what sigma star means, here it is an antibonding orbital. How the antibonding orbital is formed? By when the two wave functions are subtracted. So here this will be your answer. If they ask you then sigma is represented by, then your answer will be D. Clear? Okay. Now the second question is, I'll clear this one. Assuming that the Hund's rule is violated, the bond order and magnetic nature of B2 molecule. This is 2010 question. This was asked in 2010. So here assuming, here I told you while discussing the postulates itself, here to fill the electrons will follow Aufbau's principle, Hund's rule of maximum multiplicity and Pauli's exclusion principle. So here now the question is, assuming that the Hund's rule is violated. So here what is violated? He is asking us to violate Hund's rule. Okay, what is Hund's rule? Here pairing up of electrons in the degenerate orbitals takes place. When the pairing takes place, after each one in the orbit gets one electron, then only you pair the electron. That is Hund's rule. Now he is asking us to violate that Hund's rule. Okay, then here he has given B2 molecule. So here boron, with an atomic number Z is equal to 5. So it is B2 molecule, 2 into 5, 10 electrons. So if the electronic configuration is less than 14, less than 14 means what will be the electronic configuration? Sigma 2s2, sigma star, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and pi 2px is equal to pi 2py. So here 8 electrons altogether, and next to 2 electrons we have to fill. How we fill? 1 electron, because we follow Hund's rule. Okay, but he is asking us to violate Hund's rule. So here pairing starts here itself. So 2p2. Now he is asking us, by violating Hund's rule, you calculate bond order and magnetic nature he is asking. So here, what is bond order? Half of the difference between number of bonding and number of anti-bonding. I told you, no, here K, K dash, K, K star, and here K, K star whole dash. Now you violate this one. Okay, there will be no difference in your answer. So here how many bonding? 2 minus 0. So which is equal to bond order 1. Okay, for the bond order 1, here are two options, A and C, and here diamagnetic and paramagnetic. So here obviously paramagnetic means if the previous molecule, if we follow Hund's rule, unpaired electron, it is paramagnetic. But here we are violating Hund's rule. Here the electron is paired up, it is diamagnetic. So bond order 1 and diamagnetic. Clear? This should be your answer. Clear? Okay. We'll catch up in the next video with some more questions. Okay. Bye.